Welcome to this video. The main issue that I want to tackle here is the basics of wireless redstone, at least the method discovered by 202 Name and expanded upon by cubicmetre and some members of the SciCraft server. As far as I'm aware, that's who has worked on this the most. Wireless redstone is a very, very useful thing, mostly for ender pearl stasis chambers. However, if you're also into long-distance private communication, it can be very, very useful sending binary, but I'll get to that in a minute. First, you need to understand how this works. There are two main things you need to understand, and that's item tick detection and tile tick update order. So the first thing is, whenever you do something in the game, every game tick, something is scheduled to update. And so if you power something, it will be scheduled to update. And in our case, we can actually see here, different length repeaters will have different priorities to update. And so we can create strings of them in order to precisely create an order of updates. So for example, here I have this one, which is ordered 2-1, and this one is 1-2. If I go ahead and activate this, you'll see that we have output 1-2. Red is 1, orange is 2. If I swap these, you will see it output 2-1, like that. And we can use this prioritization of repeaters in order to create very, very precise outputs. You can see here I have 6 command blocks lined up. If I trigger that, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And it's very, very useful. The next thing you need to understand is something about item IDs. Whenever you dispense an item, it is assigned an item ID. It creates an entity, which is an item, and it is assigned an ID, and it's just a numerical value. In order to optimize Minecraft, in order to optimize the flow of the game, these items will actually start falling at different times in groups of 4, or every 4th item, in order to optimize processing. So if you see here, if I do summon, let's see, how do I summon an item? Here, I'll be right back so I can do a better demonstration. All right, all better. I got everything worked out. Go ahead and teleport back up so I can give you a demonstration of the item optimization. So essentially, let me go ahead and do this. I'm going to spawn in some items way up there. I'm going to teleport up. You can see them resting. It means that every 4 items, it will fall in a staggering pattern. Or for every group of 4 items, it'll start staggering. As you can see, 1, 2, 3, 4, 1, 2, but there's only 6 here. And what we can do is detect that change in falling, or detect that change in fall time to get specific items, or to, how best to put it, how to determine if 2 items are in the same phase, because it splits these items up over 4 phases. So I have a little machine here. You can see this is 4, or it's 3, 2, 1, then 2, 3, 1, and 3, 1, 2. It means that red will trigger first, orange will trigger second, and yellow will trigger third. These 3 channels will trigger in that order: red, orange, yellow. And so I have these 3 droppers deactivated. So if I go ahead and drop, this is a little mechanism that is able to detect when the items fall in the same game tick by using a very simple little mechanic, and that's by using this budded dropper. Basically what happens is whenever this redstone line turns off, it's powering this dropper, but it's also indirectly providing power to this dropper, but this dropper doesn't know it yet. And so if this dropper is being powered at the same time that this rail is powered, this will activate because it has been updated by this rail. And so what's happening here is we have red and yellow. Red is being triggered on the first phase, yellow is being triggered on the second phase. And so they're scheduled to update red, orange, yellow, and because we're not doing anything with orange, it's just red and yellow. However, if I go ahead and allow the orange channel to activate, you can see that it activates the output. Because what's happening is red is getting dispensed, and then 1, 2, 3 orange items are getting dispensed, and yellow ends up on the same phase as red. And so if I go ahead and turn it back off, you will see it'll reset. This design is really nice because it is it stores the last transmission, so you won't have just a pulse. It'll store and store and store, and you can read it consistently, and you won't have to worry about missing a pulse. Now, there is a little bit of an issue here. What happens if I want to receive at 2 separate locations the same transmission? For example, for an Ender Pearl Stasis chamber network, what happens if I want to receive data from one transmitter at multiple locations? Here's the issue. Each receiver has to drop 2 items, red then yellow, or red channel then yellow channel, and it'll squeeze items in between. So there's the transmitter and there's the receiver. Here's the issue. Receiver 1, receiver 2, receiver 3, receiver 4. Or 1, 2, 1, 2. But whenever I place the filler items in, you can see that 1 and 1 don't line up, and 2 and 2 don't line up. They're not in the same phase anymore. Which means that with this design, it is not possible to receive one transmitter's output at multiple places. To fix this, an amazing discovery has been found, and I can't remember the name of the person, but you can find their design on cubicmetre's channel on the first wireless redstone video that cubicmetre did. And it essentially works like this. If I go ahead and activate this, you notice that it's a similar setup. However, this rail line, if you watch closely, is triggering 3 times, fires 3 times. What this does is measure over a longer period of time exactly 2 phases worth. And so what this does is effectively eliminate 2 phases, and it just basically means that there is a binary phase system of on and off. And the organization of phases and filler items in measured items is called a protocol. And so this protocol was developed, and it is really cool. Let me grab some white concrete to show you how it works. It's the one that I use. But there is a slight issue if you're trying to use binary with it, and I will show you how to work with it. So what happens is, let's say we're working with 4 bits. 1, 2, 3, 4, and here is our measuring item. This is where it's very special. You see, the update order of rails, whenever it's powered, starts at the end and works its way towards the power source, which means this will be triggered first, and it will activate this dropper, and then it will activate this dropper here, dispensing an item. So it does the measuring item first, and then 1 filler. And then the next channel activates and does 1 filler, next channel filler, all the way down to this last one. However, it dispenses its filler item before it dispenses its measurement item. Oh, we have a little bit of item loss, but that's to be expected. So, what this means is, this bit, which we'll call a comparison bit, is out of phase with all the rest of the receiver. So, with the transmitter queued up over here with the receiver, what it will essentially do is whenever we fire the transmitter for the red channel here, and then we dispense all the rest, and boom, 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 you can see that our red channel is in sync with our comparison bit, which means that we are able to put them in the same phase and detect that. Now, the reason that this binary system is necessary to do that is because let's say that I have multiple receivers, which is characterized, let's just do a 2-bit system. It functions exactly the same way, no matter how many receivers you have. And so if I go ahead and, let's say, activate the orange channel, it's still going to do the one filler bit at the very end. You can see it activates right there. Now, here's the funny thing. The input to send this signal was 0, 1. However, you can see that the red channel and the orange channel are in line with the comparison bit, which means that the output is going to be 1, 1. And this is just an interesting quirk of the protocol. But it is not very hard to work around. In fact, the way that bits interact and integers interact follows 2 very simple rules. Now, because of the way the system is set up, because I'm in a single-player world, it does have some interference, so you'll notice some weird outputs every once in a while, and I'll note them for you, because sometimes it's just not supposed to trigger, but it does. So let's go ahead and give it a spin. Let's activate it, get it synchronized, running off this clock, so you can see my input is all zeros and my output is all zeros. So watch what happens if I activate the rightmost bit. Give it a second. It fills up the entire thing. But we can notice a pattern here. If I activate the 4th bit, the left half is going to turn on, like that. So the bits follow a very, very simple pattern. On the transmitter side, if a bit is activated, it will generate a carry over, and for every unactivated bit, it will propagate that carry, as you can see. However, if you activate a bit and the bit to its right is activated, it will turn itself off and stop the propagation, which means that if I flick this lever, my output should be 0, 0, 0, 0, 0, 0, 1, 1. And there we are. And that's it. It's not super hard to do. So for example, if I wanted to have the number, let's do 10, 10, 10, 10. So 10, 10, 10, 10. So this needs to be 0, this needs to be 1. However, this needs to be 0. So we have to activate that so it stops the propagation and turns itself off. Then 1, 0 needs to cancel this. 1, 0 to cancel that. And then finally our last one. So now if we give it a second, 10, 10, 10, 10. And it's just, you have to follow that pattern. It's possible to actually work this into an encoder before sending. It takes up a little bit of space. I'm personally working on an encoder design that will follow the pattern, so I don't have to worry about creating a whole stretch of instant wire with outputs and everything. But that is the basic thing. Now, the practicality of this machine. The implications for its use are incredible, mostly for ender pearl stasis chambers, because the near instant activation over an arbitrary distance is Very important. So if I go ahead and drop a pearl here, I'm going to teleport to a machine that I have set up. It's going to be at 100,000. 100,000. So I am approximately 140,000 blocks away. And you can see that I am chunk loading this. Weird. Here. I'll drop a whole other stack in there to keep this running. Just a quirk of this particular chunk loader design. So as you can see here, I have the same clock rigged up, and I have it put on 4, 3, 2, 1, and 1, 2. Remember earlier that 2, 1 will trigger before 1, 2. And so this is a fun little design on this machine, is that you are able to encode for a transmitter or a receiver. So all you have to do is you do your channel designator for your receiver, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. And then you have to set it to receiver mode 1, 2, 1. And then for the transmitter, it is the same channel code, but you switch the bottom one to 1, 2, which essentially doubles the number of bits that you have access to. So one other thing is, because of the time it takes, or rather just because of the timing on this, sometimes it's possible to have the clocks synchronized. One will trigger, then the other, then the other, then the other, instead of triggering at the same time. And so sometimes you have to mess with the synchronization until you get it right. But it's a really simple clock, so I don't fuss too much. However, you do need a more advanced synchronization clock if you want to transmit signals in the nether or the end. So if I go ahead and activate this, let's see if it teleports me, and it did. Good this time around. But the most important part, as you can see, from over 140,000 blocks away, it is activating this single bit. So this means, well, it's also not really extraordinary when you think about how the machine works, because the way entity IDs are processed, it's over an entire dimension, and then the synchronization of this clock globally. It's just a really, really nice feature that you can communicate a signal over an arbitrarily long distance. I'm going to go ahead and teleport back and deactivate it. Actually, yeah, let's leave it off, and then I'll teleport back home. Head back home, and let's find it. Where'd you go? There you are. And so that's actually most everything. I'm going to do a quick, let's say, here we are. This is an important thing. For you Redstone nerds, I'm sure you'll be able to figure out this design just by looking at the side profile, and I'm sure you'll be able to copy it. But I'm going to go ahead, well, I'll just do a side profile rundown, explain how everything works one more time, and just rewatch this section of video. I'll do side profiles of this one, and I'll do a top view of the piston timings here. You can go ahead and catch it right there. Pause the video if you need to, and we're back. Here is a side profile of the receiver section, and let's do a side profile of the transmitter section. The transmitter is not really simpler, but the main thing you have to look out for is this. This rail is exactly 8 blocks long, and you have to make sure that this is hooked up at the end so it will fire first, and then this will follow. And so the transmitter over here, a very simple, well, this isn't the transmitter, this is the comparison bit, that's my bad. So I'm going to go ahead and finish construction of this transmitter. I tried recording this video a second ago, but it didn't quite work. So 4, 3, 2, 1, 2, 1. So for our first one, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1, and then 1, 1, 2 for the transmitter. We're going to want to get this set up correctly with a monostable. I'm going to get an activator rail, and place it here. Let's place it there. Get an observer facing up, and let's get this, this, and this. And so for this transmitter, place this here, this here, this here, and this here. And that's really all you need for the transmitter. You can change up your activation circuits as long as it works like this, where it is the delay of the channel, the monostable, and an observer up from a rail. Let's go ahead and put the transmitter items in. I'm going to go ahead and actually deactivate it for now. And you can see that will be out of sync and out of sync. But let's go ahead and connect this, and it should now be in sync. Come on, let's see. And this is what I was talking about earlier. That is deactivated. Because it's a single player world, I've had some personal trouble. Let's try setting this to 1 and see what happens. There we are. And if I deactivate this, it should turn back to 0. For some reason, it doesn't really like to work on single player worlds without a lot of fiddling. So whenever you actually work on this system, you have to work with it a little bit in a single player world. Calibration, once you've done it on a multiplayer, is perfectly fine. But overall, yeah, that is the entirety of the system. It functions extremely well. This design is one wide tileable. One thing, make sure you alternate so that the items don't pick each other up and clump together. Also, make sure that you are using a 64 stackable. I think a 16 stackable will also work because this needs to have an output of 1 so it can be one wide tileable. Because if you use like a shovel, I found this out the hard way. If you use a shovel, a completely non-stackable, and toss it in there, it's going to overlap here. See, it overlaps, which isn't great. But yeah, that's pretty much it. Here is a side view of the transmitter. And I'm probably going to be making an Excel spreadsheet of all the lengths, or not the lengths, but the 120 channels. You probably won't really need it, but I find it a little bit useful. But actually, I probably won't. I'm not sure. Say it in the comments if you need it. But you can also find cubicmetre's world download on their video. And overall, thanks for making it this far. I hope you're able to implement this in your multiplayer world for whatever purpose you may need.